Good morning, everyone. All right, so yeah, things are going to work a little bit different today. So if you haven't already, please take out your notes. All right, we do have the links towards the bottom of the chat. The answers to the brain stretch this morning are actually going to be number 2 in our notes this morning. So we're starting the notes off a little bit earlier than usual, but that's just because we have a lot more to get through in this lesson. Maybe not in quantity, but definitely in the amount that we have to teach you guys. All right. So I love seeing the participation out there. In particular, I'm seeing Ronnie and Allie and Mike out there. So great job, everyone. Let me start the recording before I forget. Oh no, it is already going. So yeah, the molar mass of krypton is always going to be that decimal number. So it's going to be 83.798 grams per mole. And then remember, the amount of atoms always in 1 mole of krypton, but it can be 1 mole of hydrogen, it can be a mole of oxygen. Any element, it could be a mole of anything. A mole is always 6.02 times 10 to the 23, but our units here are going to be atoms. All right? So go ahead and write down these answers for number 2 in your notes and raise your hands when you're ready to move on. Just try to bear with us because the start is kind of working a little bit different than usual. All right, and if you're just walking in, please scroll down to the bottom of the chat, and toward the bottom there should be some links to the notes for you to open. And try to get at least try to get these answers written down somewhere, or take a picture of them so you can write these down for number 2. All right. Yeah, I'll give everyone a second, Julia. Yeah, no problem. Just want to call on names though, just to get stuff moving. No pressure though. Just looking for John, Callie, Anthony, Karime, Douglas, Angela. You're on a phone, so you can send a chat if you want. And then Jaden and Mary. So let's keep getting those hands raised. Again, a little out of the ordinary, which is fine, but we can adapt. Awesome. All right, so looking for Callie, Anthony, Daniela, and Angelo. If you want to send me a chat, that'd be awesome. All right. Again, this is kind of like doing 2 things at once. We're opening our notes and we're writing down the answers for number 2. Okay, Dima, I believe you just entered in. All right. Let's move on. We can always come back to it if we need to. But really quickly, just some disclaimers. Please don't share any personal information during class. Your participation is still required, and we are still recording these sessions and distributing them for learning purposes. All right, today is Friday, so we're at the end of the week. Yay us. And then we are talking about the process of stoichiometry today, so we'll learn what that means here in a second. Specifically, we are going to be understanding the relationships between coefficients, which we kind of already learned about, in a balanced chemical equation, along that with the moles. So we're going to use these ratios between the mole coefficients to complete calculations for how much stuff that we will get at the end of a reaction. All right, we already took out our notes, so we're going on that front there. And here we are with some reminders.
Awesome. All right. So again, I am going on maternity leave in a week. So really recommend that you are coming to office hours. I have been having office hours all week at 2 p.m. And I will have them all week next week at 2 p.m. as well. So definitely, thank you, Danielle. Definitely make sure that you are coming to those office hours to get help on projects. Remember, we have our Unit 1 food project, Unit 2 element project, and Unit 3 friendship project. Really recommend make sure that those are submitted before I leave, just because we don't know what the sub situation is, and I want to make sure that you have as much support as possible before I leave, and that everything is kind of all squared away, and that you're all caught up before I leave. Thank you, Julie. And then don't forget that the Unit 4 project is being replaced with an exam because I'm leaving, as well as don't forget that you will have your normal final exam. All right, so let's go ahead and get started. We're going to go ahead and do our brain stretch, but again, really recommend take advantage of those office hours.
Storm this morning, guys, is going to be a simple one. We're going to complete the sentence using this multiple choice here. So in one blank, we have 6.02 times 10 to the 23rd atoms / particles / molecules. All right, again, in chemistry, we can have a mole of lots of things, but usually we're either talking about atoms or molecules. Particles is kind of like more of a general term, but again, what's the animal that we associate with this number? All right, it's also pictured off to the right here as kind of like a small hint. All right, use your whiteboard tools. Let's circle it or box it. Awesome. Yeah, exactly. It's going to be a mole. So a mole is what we call Avogadro's number. So please, for number 3, mark this in your notes for number 3. All right, I'll start a brand new timer.
All right, everyone. So let's go ahead and talk a little bit about our balanced equation and how it's related to moles. So we've been talking about these things kind of separately, but they are actually related to each other. So here's the deal. When we talk about those coefficients that we use, those big numbers in front, in order to balance our chemical equation, those coefficients can indicate one of two things. The first is if you're talking small scale, it can tell you the number of individual atoms or molecules that you need for the reaction. So taking a look here, it could say literally, I need 4 atoms of iron, 3 molecules of oxygen, O2, to make 2 molecules of iron oxide, Fe2O3, right? Now, those are really tiny. You can't see those really tiny ones. Smiley faces emojis in the chat if that makes sense. So you can use it to talk about individual atoms or molecules that are so tiny that you and I cannot see them. Excellent. Smileys emojis if you understand. Great. Now, on the other hand, we can actually also scale this up and use it to talk about moles. So instead of talking about individual atoms or molecules, we can actually talk about entire moles. And moles, again, are really big. They are a ginormous amount of atoms, and so that's an amount that you and I can actually see. So instead, I could say that for every 4 moles of iron, which you can see up here, I have 3 moles of O2, and every 4 moles of iron and 3 moles of O2, I can make 2 moles of iron oxide. Now this is an actual useful amount because I can see 4 moles of iron, I can see 2 moles of iron oxide. I can't really see 3 moles of oxygen just because it's invisible, but I could see like the tank in which that is stored. So that's a useful amount, and it's a big amount that could be used, for example, in a factory or in a lab. Okay, so that's why we want to focus on, now we're going to go ahead and move away from talking about individual atoms and molecules to talking about moles, because moles are much more useful to us in everyday life. All right, so let's go ahead and actually practice this, and this will make more sense. All we're going to do is we're going to go ahead and actually read the equation here. Okay, so for example, in this equation it says if we have 2 moles of oxygen, which you can see here, I have 2 moles of oxygen in my equation, then how many moles of carbon dioxide would be formed? I just need to read the equation. Tell me in the chat, what is the coefficient of CO2 here? Again, it's a blank. Blanks mean what? For every 2 moles of oxygen, how many moles of CO2 are being formed? Thank you, Micah. Thank you, Landon, Monse, Ronnie, I see you. Let's get Elijah in the chat. Allie in the chat. Thank you, Douglas. Thank you, Julie and Thalia. Let's get, thank you, Elijah, Jaden. Awesome. Let's get Andrew in the chat. Thank you. I see you. Peter and Gustavo. Awesome. Yeah, that means I need I can form 1 mole of CO2. Again, just reading the equation here. So CO2 has no coefficient. No coefficient actually means 1. This is going to be the answer to number 4. It's multiple choice. Go ahead and grab that one. So just reading the equation, we're forming 1 mole of CO2. You have 20 seconds. It should be fast. Raise your hands.
Just did. However, this time, if we have 2 moles of oxygen, so O2, how many moles of water, H2O, will we form based off of the equation we can see above? So if we take a look at the coefficients, we have a coefficient of 2 in front of O2. So that matches with how many moles we have. So then, based off the coefficient in front of water, how many moles of water will we form? Gives us 2, and we have 2 moles here. How many moles will we form of water? All right, I've got Micah, Julia, Monse, Douglas, Landon. Yeah, exactly. It's going to be 2 moles of water. All right. This will become more like second nature to us the more we practice this. So for number 5, go ahead and write that answer, or not, just mark the answer because it's multiple choice. Mark that answer in your notes for number 5. And then go ahead and raise your hands again when you're ready to move on. And of course, people who are on a phone, go ahead and send me a chat when you're ready. I'm sorry, I read it backwards. How many moles of hydrogen do we need to create 2 moles of water? We're working backwards now. So if we just, as a hint, just circle this, right? It says we have this, right? How many moles of hydrogen would we need? So I'll draw, this is what we have over here, and the other one is what we need. But again, still looking at the equation, right? If you need any help or want to check your answer, we'll be in the Q&A chat, but please do not post any answers in the main chat.
Okay, so here's the deal. We can use this idea that these represent moles in our chemical equation to work even if we have different amounts. So imagine that this is kind of like your recipe, all right? And if you had a cake recipe and you wanted to double the amount of cakes, you need to think about what do you need to do to the ingredients. So in the same way, if I want to double the amount of water here, what do I need to do to everything else in my equation? Tell me in the chat. So same thing, if I want to double the amount of cake, what do I need to do to the ingredients? Same thing here, if I want to double the amount of water, what do I need to do to the reactants? Go ahead and tell me in the chat. I see Micah, I see Ronnie. Excellent, get your answers in the chat. Think about if I want to scale something up, what do I need to do to everything else in that recipe? Yeah, exactly. So if I want to double the amount of water, then I also need to double the amount of everything else. So taking a look here, doubling the amount of water here would mean that I would have 4 moles of water. But again, to keep things balanced, I have to make sure I double everything else. So this would become 4 moles of hydrogen, and this 1 would become 2 moles of oxygen. So this right here is still balanced, because if I double one thing, I just double everything else. Just like in a normal math equation, whatever you do to one side, you need to do to the other side. Go ahead and give me a green check, orange X if that makes sense. Green check, orange X if that makes sense or does not make sense. Again, if you want to double your recipe, you got to double the ingredients. Excellent. Elijah, green checks or orange X. Kathy, Karime, Gustavo, Thalia, David, Callie, get me those green checks or orange X's. Beautiful. All right, so let's go ahead and fill this in for number 7. To double the amount of water, we need to also double the amount of moles of the other chemicals. Fill in the blank with the word double, only the word double. Spell it correctly, but capitalization does not matter. Spelling does, capitalization does not. 20 seconds to raise your hands. Now, the problem is, right, if I'm talking about doubling a recipe, that's not too bad. But what if I want to multiply a recipe by 200 or 1,000 or 1,000,000? What if I want to multiply my chemical equation by 7.3, all right? So once we start getting into more complex numbers, we need to go ahead and figure out how we can do this in a more mathematical way. So in order to do this mathematically, we can use what are called ratios. And ratios are just when we write the moles in fraction form. Okay, so let's go ahead and take a look at an example here. So we have 2 moles of H2 in our equation and 1 mole of O2 in our equation. So what I can do is I can write that as 2 moles of H2 over 1 mole of O2. And this should be a 2. Or you can actually even flip that. So you can write any kind of ratio that you want depending on what you need in your problem. So these are all the different possibilities of ratios that you could get from this specific equation. So I can even flip them, right? I could say 1 mole of O2 over 2 moles of H2. Okay, same thing, I could also do this with a different set of chemicals, right? Let's say I want to take a look at the ratio between hydrogen and water, right? There's 2 moles of H2, 2 moles of H2O. So you can see that right here, 2 moles of H2 over 2 moles of H2O. Or again, you can flip it, all right? And you can see that last version with the ratio between O2 and H2O and flipped. All right, so these ratios, again, are just written from the chemical equation. Go ahead, give me a smiley or an emoji in the chat if that's beginning to make sense. Again, right now, all you need to know is that you can write things as ratios. That's all you need to know, is that from my equation, I can write things in fraction forms as ratios. Okay, now what we're going to do is we're going to go ahead and actually use this in a process called stoichiometry. Now I'm sorry to say, but stoichiometry, there's no good way for me to teach you stoichiometry without you just trying it. So we're going to just go ahead and try it. It's kind of like being thrown into the fire, and I know it'll feel uncomfortable at first, but the more and more you practice, the more and more comfortable you will feel. So we're going to do 2 practice problems together. The last one you have to finish on your own, so please make sure that you are practicing, because again, you will feel much more comfortable the more you practice. So I know it starts out feeling confusing. That's okay. Live in that confusion and just power through, and it'll get better. Okay, so here's the question. The question is, based on this equation, right, iron plus oxygen gives us iron oxide. How many moles of iron would you need to produce 20 moles of iron oxide? Okay, so here's what we do. In stoichiometry, you always start with what you know, which we say is a known quantity or a known number. So taking a look at the question here, where do you see a number? What number do you see in this question? How many moles of iron would you need to produce 20 moles of iron oxide? What number do you see here? It's not a trick question. Find the number. Thank you, Stephanie. Thank you, Landon. Thank you, Micah. Always start with the number that you have. Thank you, Monse. Again, practice. We have to do this on our own in just a little bit. Yeah, we're going to start off. We know that we have the number 20. Now, I need to include both the units and the chemical. Now, this is important. You can't just say you have 20 moles because we have many different chemicals here. So we have to specifically say moles of iron oxide. So I'm going to start off with what I know, 20 moles Fe2O3. Okay, again, MOL stands for moles. 20 moles of iron oxide right there. Okay, so now when we do stoichiometry, stoichiometry uses a lot of fractions, and it's a lot easier if you make your known, what you start with, also into a fraction. Now, to make any number into a fraction without actually changing its identity, you just put it over the number 1, because anything divided by 1 is still itself. All right, so you can see that right here. We're just going to go ahead and place it over the number 1. Smiley faces emojis if you feel comfortable with that so far. We just identified what do we know. We know we have 20 moles of iron oxide, and we're going to make it into a fraction by putting it over 1. That doesn't change anything. Anything divided by 1 is still itself. Amazing. All right, now here's where it gets a little bit tricky. Now, we don't want moles of iron oxide. We actually want moles of iron. So I need to use a conversion ratio, which we just talked about. Okay, now to figure out what ratio I need to look at the units. So starting in my known, I have on top moles of iron oxide. In the next step to get rid of it, okay, it needs to go on the opposite side. So tell me in the chat, if it's on top in the first step, where does it need to go in the next step to be on the opposite side of the fraction, the top or the bottom? Be the opposite. It starts on top, so in the next step it needs to be on the, yes, the bottom. So let's go ahead in the next step. I'm going to go ahead and put moles of Fe2O3 on the bottom. No numbers yet. We're just looking at the units. Just looking at the units. Okay, so that looks great. Now, what goes on top is what we're solving for. So look at these question words, how many, and tell me in the chat, what am I solving for? Both the units and the chemical. Units and the chemical. What am I solving for here? How many what? Moles of what? Again, we also need the chemical. Moles is the unit, but what is the chemical? Moles of what? We're on the right track. Let's keep it going. Thank you, Stephanie. Thank you, Monse. Thank you, Micah. Excellent, Landon. There we go. Moles of what? Let's practice, practice, practice. We got to do this on our own in just a little bit. I know it's uncomfortable, but the more you practice, the better you will feel about it. Yeah, we're solving for moles of iron. So on top of here, what I solve for is moles of iron. MOL space Fe. Okay? So this has given us, all right, our conversion ratio. Now, the only thing we need to do is fill in the numbers. The numbers for a conversion ratio always come from the balanced equation, just like we saw on the previous slide. So let's go up to our balanced equation and take a look at that. So moles of iron. Tell me in the chat, how many moles of iron are in my equation? In my balanced equation, what is our coefficient? How many moles of iron are here? Thank you, Landon. I see Stephanie, David, Monse, Micah. Excellent. All correct. Yes, we have 4 moles of iron here. Now, how many moles of iron oxide do we have? Take a look at its big number, its big coefficient. Big coefficient in front is 2, so yes, it has 2. Okay, great. So we have our equation now filled in. Now this actually gets easier, all right? Once you've set it up, it gets a lot easier because multiplying fractions is super easy. You just multiply across the tops and multiply across the bottom. So on top, we have 20 times 4, and on the bottom, I have 1 times 2. So let's go ahead and do that in the chat. What is 20 times 4? Okay, multiplying fractions, this is just math. Just multiply across the top, multiply across the bottom. Easy peasy. 20 times 4. Thank you, thank you. Let's get Elijah, Allie in the chat. Haven't seen you in a while. Again, I need you participating, making sure you feel comfortable with this. Andrew, Karime, Douglas, Peter. Thank you, Peter. Gustavo. Yeah, 20 times 4 is going to give me 80 on top. And what about on bottom? What is 1 times 2? 1 times 2. Beautiful, yes. Now, we have this fraction 80 over 2. But fractions, remember, are actually just division in disguise. So 80 over 2 is actually the same as 80 divided by 2. So go ahead and simplify that even further. What is 80 divided by 2? Yeah, it's 40. Awesome. All right, so let's go ahead and take a look then. So we end up with 40 here. Okay, that looks great. However, 40 what? We need to figure out what did we just solve for. So here's the deal. Remember I said that when you have a unit on top and a unit on the bottom, they actually cancel out or divide out. You could say cancel out, divide out. So moles of iron on top is going to cancel out with moles of iron on the bottom in the next step. So all I'm left with is moles of iron. All right, so that's my final units here. And tell me, based on our question where it says how many moles of iron, is that what I was solving for, yes or no? If my final units here are moles of iron, and the question said how many moles of iron, yeah, that's exactly what I was solving for. So what this ultimately says is how many moles of iron do we need to produce 20 moles of iron oxide? Well, we need 40 moles of iron. Go ahead and give me a green check, orange X if this is beginning to make sense, if I can find my polling tools. Again, I know it's a lot. That's why we practice. This is the only way to get better at stoichiometry is just to practice it. Excellent. All right, this is going to be the answer to number 8. The first box should just be the number. All right, so first box is the number 40, and the second box should be MOL space FE. Okay, we're going to do another practice one. Again, the next one you'll need to be able to finish on your own, so make sure you're practicing with us. Let's go through this one a little bit faster. How many moles of water would be produced if you had 15 moles of methane? All right, so taking a look here, we have an equation. Methane and oxygen, when combusted, lit on fire, create carbon dioxide and water. We need to start with what we know. Take a look at our question and tell me, what do I have a number for? What do I have a number for? What number do I see here? Yeah, exactly. You should see the number 15. And its units are moles of methane. Again, we need both the units, moles, and the chemical methane, CH4. All right, to turn it into a fraction, I put it over what number? Anything over what is still itself, but is now a fraction. Anything over what is still itself, but is now a fraction, over 1. Perfect. Awesome. Now, I have moles of CH4 in the first step, and I want to get rid of it. In the next step, where does it go? What would be the opposite side, the top or the bottom? We start out with moles of CH4 on top. In the next step, it needs to go on the opposite, which would be the bottom. Exactly. Moles of CH4 goes on the bottom, not putting any numbers in yet, just taking a look at units. And on top, what am I solving for? What am I solving for? Think about how many what? How many what? Both units and chemical. Yeah, H2O is the chemical. The units would be moles. Yep, moles of water, H2O, goes on top. Now, to fill in this conversion ratio, we always go from the balanced equation. So let's check that out. How many moles of H2O are in my equation? Take a look at the big coefficient in front. Absolutely, right here, there are 2 moles of H2O. What about how many moles of CH4 are in the equation? There's a blank in front. Blank coefficient actually stands for, yeah, it stands for 1. So we have 1 mole of CH4. Awesome. Now this is just math. Multiply the tops together. 15 times 2 equals what? 15 times 2 on the top equals what? Yes, I see Thalia, Micah, Landon, Ronnie, Stephanie. Make sure you're practicing. You got to do this on your own. So Callie, David, Nareesh in the chat. Stephanie, Jaden, Gustavo. What is 15 times 2? 15 times 2 on top. Yeah, it gives me 30. And what about on the bottom? 1 times 1? 1 times 1, everyone should know that one. That's easy. 1 times 1 is 1. Yes. And this is a fraction, but fractions are just division. So 30 over 1 is the same as 30 divided by 1, which gives me what? Anything divided by 1 is still itself, so that should be excellent, 30. All right, but again, the question is 30 what? What am I solving for here? Take a look up here. We have moles of CH4 on the top here, moles of CH4 on the bottom here. That gets rid of it. It cancels out. So all I'm left with exactly, Micah, is moles of H2O. And is that what I was solving for, where it said how many moles of water? Was that what I was solving for? Absolutely. So again, what we just determined is that the question was how many moles of water would be produced if you had 15 moles of methane? Well, 30 moles of H2O. Amazing. This is the answer to number 9. First box is 30. Second box is MOL space H2O. Okay, don't need to do anything special with that 2. Just leave it as a normal 2. But do remember that the H2O, that's an O, not a 0. Go ahead and raise your hands for number 9. We got one more to go. And that was a really strong showing. I'm feeling confident. I hope you're feeling confident. Let's get this filled in. All right, so this last one you need to be able to complete on your own. I'm still going to help you set it up though, because this is a new process. I want you to feel confident. I want you to feel like you can solve the rest of it on your own. All right, but I want you to feel like you are confident with this. So the question is, how many moles of oxygen do you need if you have 14 moles of hydrogen? So the equation here is hydrogen plus oxygen gives us water. We need to start with what we know. Tell me in the chat, what do we know? What do we know? What number are we starting with? Yes, we are starting with 14. And again, the units here are moles of H2. Don't forget that you need both of those. So 14 moles H2. Now, turn it into a fraction by putting it over what? Turn it into a fraction by putting it over what? Yeah, because anything over 1 is still itself, but now it's in fraction form, which makes stoichiometry a little bit easier. In the next step, I have moles of H2 on top here. So in the next step to get rid of it, which side is the opposite, top or bottom? Where do those units need to go in the next step? You'll notice this gets very, very repetitive. Yeah, it goes on the bottom, exactly. Don't put any numbers in yet, because first we need to figure out what goes on top. So on top, that's what I'm solving for. Tell me in the chat, what am I solving for? Take a look at the question words. How many what? Give me both units and chemicals. Units and chemical. You're giving me a chemical right now, O2. I also need units though. Put it together. I got some people with just the units. There we go. All together, moles of O2 goes on top. Great. Now we can go ahead and fill it in using our balanced equation right here. So taking a look here, how many moles of O2 are in my equation? How many moles of O2 are in my equation? Yes, there's just one. It's a blank. Blanks mean 1. And how many moles of H2 are in the equation? Look at that. Its coefficient, its big number. Beautiful. Yes, that would be a 2. All right, so we have our numbers. Let's go ahead and figure that out. So do not put answers in the chat. So on top, you should be doing 14 times 1. On the bottom, you should be doing 1 times 2. Don't put answers in the chat. Once you have your top number and your bottom number, remember that's a fraction, but fractions are just division in disguise. So once you've multiplied the top, multiplied the bottom, just go ahead and do your final top answer divided by your final bottom answer. Okay? Now, units here. Units are important. Taking a look up here. We're getting rid of moles of H2. And so my final answer, I should be left with moles of O2. Tell me in the chat, is that what I'm solving for? Where it says how many moles of oxygen. If I end with moles of O2, is that what I was solving for? Yes, beautiful. All right, so we are solving for the number of moles of O2. Awesome. This is going to go ahead and be the answer to number 10, or sorry, this is what you need to finish for number 10. Raise your hands when you're ready to move on if you want to check your answer. We're in the Q&A chat. Again, that second box, it's MOL space O2. Don't do anything special with the number 2, but remember that O is an O, it's not a 0. 20, 30 seconds to raise your hands or check in with us in the Q&A chat.
We connected that back to moles, and then we used that relationship to look at the ratios between moles and to complete calculations involving how many moles of something we should get out or how many we would need in a particular chemical equation. So good job with that, everyone. If you'd like to, just take some time shortly, just right now, and use your color pointers and show how you feel about today's lesson.